Long before I built this cockpit, I used to make a different kind of FSX video, and I wanted to take a look back at one of those particular videos today. And that's the one looking at some experiments I did with putting flocks of birds into FSX. And I wanted to do that for 2 or 3 different reasons. One being to celebrate perhaps one of the more useful utilities that there's pretty much ever been for filmmakers in FSX, and that's FS Recorder. I guess it's also a bit of a lament in a way. That utility unfortunately is not available to us in Prepared, and in fact in recent months it's not even available officially anymore for FSX. The official FS Recorder website has disappeared, although it's still downloadable from many of the file sharing sites. So FS Recorder in a nutshell is a program by Matthias Neusinger, I think his name is, and at its simplest it's a replacement notionally for the FSX built-in record and replay function. But it's a lot more than that. I think a lot of people who have heard of FS Recorder and perhaps have even used it don't really appreciate how flexible it can be. And in particular the complex air-to-air shots that you'll see in many of my videos. So let's see my Battle of B-25 video, Spaceship Zero, and in particular the Ryan STA video for Golden Age simulations. That was a great example of the, those shots, those air-to-air shots just can't be done any other way in my experience than using FS Recorder. But coming back to the idea of birds and flocks of birds, one of the things that FS Recorder can do which makes it extraordinarily powerful is if you record your flight in FS Recorder, it's important to say this is not a video recorder. This is not recording a raster image video sequence. It's more like a data logger. It's recording the instantaneous position and many other parameters such as the heading and orientation of your aircraft fundamentally at multiple points in time. And you can record, let's say, 10 times a second or 20 times a second, and then you can play that back. And of course when you play that back you can then change the view to observe the aircraft from different angles. So it's like, you can do multiple takes if you're shooting a video and film the same thing from many different angles and all sorts of things. But what's really interesting is that recording of the flight is editable, so you can load that up into a text editor with a little bit of tap dancing, it has to be said, and then you can play about with it. Or the other thing you can do is you can generate, if you know the format of the scripts, you can generate them from scratch, and indeed that's what I've done in generating the flocks of birds. Now the reason I wanted to do this in the first place is that for a long time I've been interested in the simulation of flocks of birds, and in fact ever since I read this book back in the 90s, this is a book by, can you see that, Stephen Levy, it's called Artificial Life. I'm not sure if it's still available, but I would highly recommend this book. It's still a fantastically interesting read. But one of the things it covers in here is the work of Craig Reynolds, who was, or still is, a computer graphics researcher, shall we say. And he's most known for something called Boids, which is a simulation of bird flocking. Now what Reynolds did was he came up with an algorithm that seemed to produce lifelike flocking behaviour, and he wrote about this, his seminal reference is a paper called Flocks, Herds and Schools, a distributed behavioural model. And in fact, just to keep the nerd factor up, I have a copy of his paper here. This was actually sent to me by Craig Reynolds in 1993, according to the postmark. Now this is before, you have to remember, this is before the World Wide Web made everything available from everywhere 24/7. So I emailed Craig Reynolds and asked about if his paper was available anywhere, and he sent me a copy of it and a few other papers. So that's the original paper, and of course these days you can just Google Boids or Craig Reynolds and you'll find all sorts of references and of course implementations and apps that will allow you to play with these things. So you can read about Reynolds' algorithms, but getting back to the plot, I wondered if it was possible to use these ideas to generate realistic flocks of birds in FSX. Now one of the other really interesting features and really powerful features of FS Recorder is you can record multiple aircraft at the same time, and you can play them back as AI traffic in FSX speak. That means you can have, in theory, an arbitrary number of aircraft flying on a single script. And of course, if you create your script methodically, you can have complete control over the positioning and the orientation of those AI aircraft, we'll call them. So theoretically, if you had an appropriate model that looked like a bird, you could position groups of these things to represent flocks of birds. Or you could have, large formations of aircraft, of course, which is more traditionally what people do with FS Recorder. So we'll have a look at how I used that idea and took it forward and actually managed to produce some flocks of birds. So what are the problems we need to solve to go from that as a concept to actually having it play out in a video? Well, let's say we want to generate a flock of birds. Let's say 500 birds is a good size for a flock. It's a big flock. We need to do two things. First of all, we need to generate the data for the positioning and the orientation of the birds. That's a task in itself. We'll look at that in a minute. Then we have to get that data into a form that's understandable by FS Recorder, and then I guess we have to play that out and film it. So that's 3 steps really, not 2. Now along the way there's a number of barriers to feasibility here. Now, 500 AI aircraft being coordinated in playback, you don't have to be an Einstein to recognise that's quite likely to cause or have some implications for performance. And indeed, if you wanted to play that back in real time and film it, that's a non-starter. That's not going to really be possible. Anyone who's played with AI aircraft and FS Recorder will know that. But there's one other feature of FS Recorder for which you need the latest ever version, because that introduced a very powerful feature which kind of changed the game really in terms of FSX filming. There are alternatives these days, but it essentially produced a video rendering option piggybacked on the back of your playback. So you could play back your script and you could specify some options to render a video during playback, and the key thing is it would render the video in non-real time. So essentially FS Recorder would use the FSX graphics engine, I suppose you might call it, to render the frames one at a time. And you could use the highest settings in FSX. You have the best weather settings, the most complex video rendering, highest resolution, and all it meant is the rendering of the playback would take longer, and then it would play back completely smoothly and allow you to create a video at an arbitrarily high frame rate. So you could, if you wanted, get 60 frames per second with the maximum quality FSX rendering, and it would play back with beautiful smoothness. Now by and large that worked really well, and I've used that technique in quite a few of my later FSX videos, particularly, as I say, doing the air-to-air shots. So then moving on to how to generate the data. Now over the years I've tried my own experiments in creating flocks from computer programs, and have been particularly successful with that, mostly because I don't know much about programming 3D geometry. But what I did for this experiment was I found a program out there on the web and basically used that and hacked that. This is a program written under a system called processing. There's an open source project. If you go to processing.org, processing is it's got a sort of a 3D environment and programming system based on Java programming. So if you know Java, you should be quite familiar with that, or C++. Java's just C++ without pointers, you might say. I should say processing is a system designed for programming graphics applications. So there's lots of experimental code out there that people have made available that you can tinker with, and I found a Boyd's simulation. So I suppose in a nutshell I did 2 different things in hacking that Boyd's program. One is I captured all the position data of the flocking birds, and then I had to transform that or scale that position data into a form that was going to be readable by FSX. That's basically latitude and longitude information, and then I had to output that into some data files to create an FS Recorder script in the appropriate format. And then really it's a question of running that inside of FSX to play back the positions of the bird models. Right, so we're just going to have a quick look at processing. We'll look at the original Boyd's program, unadulterated. This is processing version 2.0 beta 7, I think. This is a very old version now, we're up to 3 point something if you want to get this for yourself. So this is, if I just run this, you'll see what it does. It produces this 3D, it's not a great application visually. Can zoom that in a little bit. It produces the 3D animated flock within a rectangular 3D space. So what we want to do is we want to somehow, as those birds are moving around, we want to capture those positions and save them in a form that's going to be readable by FS Recorder to animate our FSX AI birds. We just have a little brief, very superficial look at this project. We've got 3 different classes. We've got a Boyd class. This is the the Boyd individual birds or objects in this flock will be defined by this class. So we've got something. Let's see. We've got position, a velocity, an acceleration, and a bunch of other things that are tracked in here. Well, a bunch of methods to move and render those Boyds. Then we've got a thing called Boyd list, which presumably a Boyd list represents a flock, and then the program itself, if you like. So here, when the program initiates, I'm presuming setup runs first. There's only one flock created here, creates a Boyd list. So that's the basic unadulterated program, and that's written by, just to give due credit, Matt Wetmore in 2009. So we're going to come out of that. We're going to go and look at my hacked version of that. Let's run that up. So we've got the same basic program, but if we look at the Boyd class first. I've added a couple of things to the Boyd class. I think the only thing I've added is this line here. So we want to, as well as tracking the position, I think the positions are calculated in meters in this project. At each stage we want to convert that somehow to a latitude and longitude, and we save that in these 3 fields here. FSX pos lat, pos long, lon, pos altitude. I think that's calculated here in the move method, so I've added some code in here. I've calculated a working position. You don't have to know exactly what's going on here, but I think what I've done is I've created a box of a given size in meters centered on a particular latitude and longitude, which if we go back to the start of the project, you can see I've got various starting points set up here. These are in comments at the moment. The one that's active is this one, and this is a position at Israel's farm. So I've just harvested from FS Recorder what the latitude and longitude of a particular point on Israel's farm is, and I've used that as my origin. So all these points that are calculated within the Boyd program will be scaled to that box, which I think is probably like 1,000 meters wide or maybe 500 meters wide, and then centered around that original latitude and longitude. Hope that made sense. Just as an aside here, nothing's as simple as you think it is. In calculating those latitude and longitude positions, I had imagined there'd be a simple way. Let's imagine if we're starting from a particular starting point, and then one particular Boyd moves 10 meters north of that starting point. I had imagined there was just a simple way to take a latitude and longitude and then take a x and y, or north and south displacement from that in meters, and calculate a new latitude and longitude. Apparently it's not that simple. There is a complex formula to do that called haversine, if you want to look that up. There are various approximations to doing that offset calculation, which I've used one of those here. I can't remember the details, but this, you can see here I've calculated a working position and then applied a formula based on the radius of the Earth and various trigonometric manipulations to calculate the new latitude and longitude from the origin. So that's what we're doing in the Boyd class. Now obviously this original program just draws the Boyds on the screen. We want to capture those data points, those latitudes and longitudes I've just pointed at, and write them to data files. So to that end, somewhere in here in the setup I've created a data file for each independent void. So that's what I'm doing with this line here. You have to do that using this print writer class, which is I think a class supplied by processing. And then I've initialized each of those data files here. So it's one for each. So it's one for each void. The number of voids is specified in this. Sorry for all this scrolling backwards and forwards. This void num here. So we're at 100 at the moment. So here's a loop that will go around 100 times, create 100 data files, and initialize them with the heading that FS Recorder is going to require. If I just try and pull up a FS Recorder data file here, it's going to work. Try that one. Now this is not tabulated very well, but it doesn't need to be. It's not human. I mean, it's human readable, but it's not intended to be human readable, this file. But you can just say we need to create the data file with that heading describing the aircraft we're using. Interval, I think, is the time interval, which this data file is clearly being generated by FS Recorder. And then we have this, the last header is it's the column headings. So the columns are latitude, longitude, altitude, pitch bank and heading. And then these are the data fields themselves. So that's actually a latitude value. Next to it is a longitude value, an altitude, 600 and some feet, pitch bank and heading. So those headers are what we are creating when we create and initialize the data files here. If I flip over again to Windows Explorer, you see that we've actually got data files here called data hyphen then a number. These are the files that have been created in a previous run of this program. And if I just look at one of those, you can see, so at the initialization stage, that highlighted portion is what's written to that data file. Then at some point during the processing of the void list, we should find some code that writes the actual data lines to that file, and that's done here. It's in the run method of the void list class, and you can see we're getting the, did I talk about those? Yeah, these are the fields that I'd added to the void list, the position, latitude, position, longitude, position, altitude fields. So we're writing those out to the data file. This is a single line. I mean, if you know Java, you'll understand what's happening here. This is just creating a string by concatenating the position, latitude, position, longitude, position, altitude, the orientation, Y, Z and X, which are the pitch, bank and heading fields with a bit of manipulation there, and then I guess that flush method is the thing that actually writes the single line. So that statement there that I've highlighted will write a single line in one of these. So it'll write, let's say that line. So we write a longitude, latitude, longitude, pitch, bank and heading, and it's done. It goes around that loop and writes one for each void. And of course, as it goes around that loop once, it writes that line for that void to, let's say, data file 10. Then the next time around the loop, it writes that same data for the next void into data file 11, and then around the loop again for the next void, it writes the same data for a different void to data file 12, and so on. So you can see there's an awful lot of stuff going on here. And so those data files accumulate throughout the running of the program, and then at the end they are, in fact, if I show you that, we make that process end by, somewhere down here there's a thing that interprets keystrokes. There it is, key pressed. So I've added a line into here. If I press the X key, it will stop the processing. It will call a thing called batch data, which I've created, and that basically goes through and takes each of those, in this case 100 text files for each of the 100 voids, then it aggregates those into a single data file called data.txt. I'll tell you what we'll do, we'll just do an example of this, because this is kind of unwieldy with 100. I'll delete all those data files. We'll come in here, we'll run this program with, let's say, 10 voids instead of 100, and we let it run for a very short time. If I run, there it goes. If I press X now, what we should find is if we go over to Explorer, we've now got 10 individual data files, one for each of those boids. If we look at one of those, so we only ran for a short time. I think we're running at 1/10 of a second, 0.1 seconds is the interval, so we get 10 movements per second, and that's, you know, maybe like 150 lines there. So that was Boyd number 3, so it's data file 2. Look at number 7, we get a very similar looking thing. Those numbers will be subtly different. And then at the end it's run that batching process, and we've now got a single data file which has got more fields in it, but we should find at various points those headings signalling to FS Recorder that it's a different aircraft. I think that's pretty much all we need to know about what we've done there. And then of course the last step is, because this is a text file, FS Recorder can't read that, so we need to convert that back into an FRC file, and we do that by running the FRC converter program. And we want to go from text to FRC, so we click that. We select the data.txt file, and we used to give it an output name, data-frc, why not? There it is. Now we should be able to load that up into FS Recorder, play it back as traffic, and magically we should get a flock of birds. Now I can show you some various steps along the way in my experiment. I have a lot of outtakes from that original video, and one of the things that was difficult, and in fact ultimately was a real barrier, is finding a suitable bird model. Because you can animate aircraft, flocks of aircraft with this, but it looks a little bit stupid, and you want something that's on the appropriate scale. The thing, I used 2 models in my final video, at least for the flocking behaviour. I used a seagull model and I used some sort of crow or blackbird model, and these were from the Earth simulations sceneries, the Channel Islands sceneries if you had those. And the blackbird model was the most suitable I found, but even so it wasn't suitable. 2 things with that. One is it's a very crude model, and close up it looks a bit rubbish. In the distance it looks pretty good in terms of the flocking behaviour. One of the problems is, now if you are adept at creating your own FSX aircraft models, then you could build your own very simple bird model that would have probably worked better than this one. The main constraint on this was, there's a concept of, I don't know what it's called, is it fallback, or there's level of detail or something like that, but in essence you can code into an aircraft model, I understand, in FSX different levels of complexity of rendering that will be used depending on how far away the model is from the notional camera. And of course this allows you to have a very detailed and complex model close up, but when the aircraft model is being seen much further away in the distance, it can render a simple, very crude model, and of course that's a performance benefit. Unfortunately, what usually happens is, beyond a certain distance the model isn't rendered at all, and indeed in the Earth simulations blackbird model that's the case. And the consequence of that is, if you've got a flock, let's imagine a flock of birds, exhibiting complex interactional behaviour, it's in the sort of middle foreground, there's a cut-off beyond which the birds disappear. So if they're flying away from the camera, they'll suddenly disappear, and I found that was a real problem, and I didn't really know how to fix that. So that made, it's somewhat visible in the final product. If you look at how in particular the seagull flock, the seagulls seem to just teleport in from nowhere. If you look closely, it's better with the blackbird flocks, but I had a hell of a lot. I had to shoot an awful lot of stuff to get some some shots where that appearance and disappearance wasn't too obvious. So if you were going to do this more conscientiously, that's something you'd want to think about, and it would have been so much easier to have a model that stayed visible infinitely far into the distance. So that's birds. in FSX, it would be, in principle, it ought to be possible to do that live, real time, within an FSX add-on. I don't know in terms of performance whether that could ever be done to an acceptable level of performance. It'd be really amazing to be able to have realistic, live and interactional flocks of birds in FSX or in Prepared. As far as I know, nobody's done that yet, and unfortunately, in spite of how useful and really fantastically powerful FS Recorder was, it's not available for Prepared, and as far as I know, there's nothing else that does the job. There are a couple of apps that are moving in a direction, or that attempts to do some of what FS Recorder does, notably the record and playback, but as far as I know, none of those are up to scratch currently.